Hello everyone, welcome to today's class. This is Teacher Simon taking you through AS Pure Mathematics 1, paper 9709 stroke 13 for May, June 2025, and this is part 1 from questions 1 to 6. Question 1 is coming from differentiation. They are saying a curve has the equation y is equal to 2x plus 12 out of x squared. And I think it is also coupled with coordinate geometry, because they are saying find the equation of the tangent to the curve at the point -2, -1. Give your answer in the form y is equal to mx plus c. In order to find the equation of the curve, we need, the equation of a straight line, we need two things. Number one, at least one point through which a line passes, it is given, and also the gradient. But at the point of intersection, the curve and the line always have the same gradient. So we need to differentiate this equation of the curve to get the gradient function. I'll put this -2 as a power of x. Now dy dx is going to be equal to 2 here, then minus, this will be 24. Remember, we drop the power, then we reduce it by 1, right? Okay, then this will be x to the power of -3. Now, at this point here, -2, -1, dy dx is going to be 2, then minus 24 out of x is -2 cubed. Now, all the power of a negative is always a negative, so this is -8. Now, -24 divided by -8, you will get a positive 3. Not so? So meaning this one will give us a 5. Then after this, using y minus y1, which is equal to mx, m into x minus x1. So we have y, then minus, our y1 is a -1 here. So -1 then is equal to m, which is 5. Then x minus, our x1 is -2. Now this one is going to become a plus, and also this one is going to become a plus. So when I open the brackets, here I will have 5x. 5 times 2, we get a 10. Now this one, when it crosses, it becomes a minus. So -1. So our final answer then becomes y is equal to 5x plus 9. As simple as that. Question 2. The first two terms of a GP are 4 sine squared theta, 8 sine cubed theta, where theta is an angle such that theta lies between 0 and pi over 6. Given that the sum to infinity of the progression is a half, find the value of theta. Give your answer in the form arcsine of k, where k is a rational number. Rational means it can be expressed as a fraction. Okay. Now, we have the first term, a, which is equal to 4 sine squared theta. Then we have the second term, ar, which is equal to 8 sine cubed theta. If I want to get the common ratio, I get the preceding term divided by the preceding term. So this will be the second term, which is 8 sine cubed theta. Then I divide by the first term, which is 4 sine squared theta. And this one, 4 will go into 8 2 times, and sine squared theta will reduce this one also by 2, and then we get 2 sine theta. Then after that, we are given the sum to infinity, which is a out of 1 minus r. They have said it is a half. Okay. Now, what is our a? Our a is 4 sine squared theta. Then out of our r is 1 minus 2 sine of theta. Then this one is equal to a half. Then we can cross multiply, and then we have 8 sine squared theta, which is equal to 1 minus 2 sine of theta. When I bring everything this side, I'll form a quadratic in sine theta. And this will be 8 sine squared theta, then plus 2 sine of theta, minus 1, which is equal to 0. Okay, this is a quadratic equation in sine of theta. Okay, Then I can solve this using the calculator. Mod, then equation is 5, and then option number 3, that is where we are having quadratic. So we have 8, then 2, then -1. So this one gives us a quarter, and then -1/2, a quarter and -1/2. So I will leave some space, and then I write sine theta is equal to -1/2, and also sine theta is equal to a quarter. But I need to show the examiner the attempt to solve this quadratic equation. That's why I've left space here. So I need to show the examiner the factors from which these roots are coming. Okay, so I can cross multiply here. I do it backwards. So we shall have 2 sine theta. Then when you bring the -1 this way, it becomes a plus. So I'll put +1. This is the factor that gives us this. Okay, then here you will get 4 sine theta, 4 sine of theta. Then you bring the 1 here, it becomes a minus. So that is -1, which is equal to 0. Now, they say that theta is less than 30 degrees. Okay, sine is positive in the first quadrant. So in the first quadrant, we see from 0 to 90 degrees. So that means we are only going to take this positive value of sine theta, not this one, because sine is negative in the third quadrant, that is beyond 180, between 108 and 270, and then also in the fourth quadrant, that is from 270 to 360. Okay, so this therefore implies that our theta is going to be equal to the arcsine of a quarter. As simple as that. Remember, they had told us that k is a rational number. It's a fraction. That is the one here. Question 3 is coming from integration. Given that the integral of a out of 4x minus 3 bracket square, then plus 2 from 1 to 3 with respect to x is equal to 12. And then they are telling us to find the value of a. Okay. Now what I'm going to do is to first transform this into something I can integrate. So this is a. Then using rules of indices, I can take that one up. It will be 4x minus 3, then power -2, and then plus 2 here. Then from here, when we integrate this one, you increase the power by 1. You see? So you get a -1. Then you divide by that new power. But then you multiply by the derivative of what is inside here, and that is a 4. You see that? We also have an a here. Then since we have integrated, this integral sign has to disappear. Then plus, this will be 2x, and then we have 3, 1, which is equal to 12. Now, we put the limits. We shall have a here. Actually, this one, I'll take it down. Let me first take it down such that it becomes much more clear. So we have -a out of 4, then times 4x minus 3. We usually don't write the negative in the denominator, so that's why I've taken it up here. Okay, then plus 2x, and then 3, 1, then 12. Now let's put 3. So we shall have -a out of 4. 4 times 3, that is 12, minus 3, that will be a 9. And then 2 times 3 here. Then minus, we put 1, that will be -a. Then out of what? 4 into 4 minus 3. Then plus 2 times 1. Then we equate to 12. Now here we shall have, first of all, this is 12 minus 3. 9 times 4, 36. Also, we shall get 36. So -a out of 36, then plus, this one is 6, then minus. Now minus and a minus, that one will become a plus. So we shall have plus a out of 4, because this one is a 1. And then minus 2, then will be equal to 12. Okay, now what we shall do here is we are supposed to make a the subject of the formula. Okay, now this is 6 minus 2, that one will be a 4. So when I take it this side, I will subtract it. So that means I will have 8 on the other side. So I have negative a out of 36, then plus a out of 4, then this one will be equal to 8, right? Now I can multiply all through by 36 because 4 can go into the 36. So this one is over 1. Here we shall have negative a, then plus 4 goes into 36 9 times. Not so? So we shall have 9a, and then this side 8 times 36. 8 times 36, that one is 288. 288. 9a minus a, that will be 8a, which is equal to 288. So meaning here our a is going to be equal to 288, then divide by 8, and then we get 288, then divide by 8, that one gives us 36. So our a is equal to 36, as simple as that. Question 4 part A is coming, this question 4 is coming from binomial expansions. So part A, find the first 3 terms in this expansion here in ascending powers of x. Now we have this 2 minus 3 over 2 of x, then power 5. When we are expanding these terms, we have n, which is 5 for this case, then combination something. Then we have the terms are 2, which is binomial. So the bi means 2, nomial terms, you get it, 2 terms binomial. Then the other term is negative 3 over 2 of x. You have to be careful here. There's a negative on this. Okay, so you take this term with its negative. If you don't, you'll get wrong things. Now, the next one, we shall have also 5, then combination something. I can put this one here, and then also that. They said the first 3 terms, and then one more. We shall have 5, then combination something, then 2, and then negative 3 over 2 of x. Now we need to put these powers and what is in the combination. Now these terms are going to move like this. The first one here gets a power 5, then the next one is 4. So it keeps on reducing in the powers, then 3, 2, 1, 0. And then the second one begins from power 0, then 1, 2, 3, 4, and 5. Okay, so for the first one, we shall have a 5, then 0, and the power that is on the second one here is usually the one we put in the combination. So that means we shall have a 0 here, then 1, then 4. No. Pardon me here. This is 4, this is 1, then 1, then 3, 2, then 2. Okay, when you add these powers, you always get the 5 that is given here. All right, now 5 combination 0 is of course a 1, and then 2 power 5, that is a 32. 32. Then when we come to this one is going to be a 5. Okay, 5, then times 2 power 4, that is a 16, then times negative 3 over 2 of x. And then 5 combination 2 is 10, then times 2 cubed is 8, then times this one squared, we shall have 9 over 4, then x squared. And then finally we get 32. Then this one goes into here 8 times. You get it? And then 5 times 8, that is 40. 40 times 3, that is 120. So we shall have negative 120 of x because of this. Okay, And then here, 4 can go into 8 two times. Now 20 times 9. Isn't that 180? So we shall write 180 x squared. These terms are continuing. They are supposed to be 6 terms. Okay, if it is power 5, then they are 6 terms. But this is what they wanted us to get. And that is that. Then part B, use your answer to part A with a suitable value of x to find the approximation of this. Now what we can do, up here we have 2, okay, 2 minus 3 over 2 of x to the power of 5. This one, I equate it to this one given here, power 5. That means whatever is inside the brackets here, then will be equal to the 1.985, not so, because they are all to the power of 5. Then we make x the subject to the formula. So 2 minus 1.985, this one will be equal to 3 over 2 of x, and therefore x will be, when you cross multiply, that will be 2, then times 2.1, no, 2 minus 1.985, then after that we divide by 3. What do we get here? 2 into 2 minus 1.985, then we divide by 3. We get a 0.01. And now when we come to 1.985 to the power of 5, then this one will be equal to, now I just come to this one here, wherever there is x, I put a what? A 0.01. Okay, so we shall have 32, then plus, it's actually minus 120, now times 0.01, then plus 180, and then 0.01 squared. So we put this in the calculator and then we write down our answer. 32 minus 120 into 0.01, then plus 180 into 0.01 squared. This one is 30.818. I can leave it there. I can write it to 3 significant figures at 30.8. Okay, 30.8 to 3 significant figures. If we get the calculator and we say 1.985 and then we power this with a 5, the answer we get, I think you can see, to 3 decimal places, it gives me what I've gotten here, 30.818. Or to 3 significant figures, then you get the 30.8. You see that? Question 5 is coming from trigonometry. Solve the equation 4 sin theta tan theta is equal to 1 plus 5 cos theta for theta ranging from negative 180 to positive 180. Now, here we shall have 4 sine of theta, then times tan theta is the same as sine theta over cosine of theta, which is equal to 1 minus, plus 5 cosine of theta. Now, everywhere, I can multiply by cosine of theta such that I eliminate this denominator. So when I multiply it here, automatically the cosine will cancel with that, not so? And then we remain with 4 sine squared of theta, which is equal to 1 times cosine of theta, that will be cosine of theta, then plus 5 cos squared of theta. Using the Pythagorean identity, since I'm seeing a cos theta here, then I have to express sine squared theta in terms of cos squared theta. So we have 4, then 1 minus cos squared theta, which is equal to the cosine of theta, then plus 5 cos squared theta, open the brackets, this will be 4, then minus 4 cos squared theta, which is equal to the cosine of theta here, then plus 5 cos squared theta. Now we can collect like terms together, and then, or we put everything on one side, and then we form a quadratic in cosine of x, cosine of theta. So take everything this side, this 4 here will add up to the 5, and that one will give us a 9 cos squared theta, then plus the cosine of theta. When the 4 crosses, it becomes a minus, so minus 4. Then this one will be equal to 0. Okay, then after this one, we can solve this. I can see when I multiply this, when I multiply these two, I get negative 36. They are not two numbers. When I multiply them, I get negative 36, and when I add them, I get a 1. No, they're not there. So I can show the examiner, okay, that I've solved this equation. Remember, even this one, you can write it, I mean, you can solve it using the calculator, but the calculator is going to give you non-exact values. You get it? But you have to show the examiner that you have attempted to solve the equation. So you show the examiner that you have substituted in the quadratic formula. So cos theta is equal to minus b, then plus or minus to the root of b squared minus 4ac, then out of 2a. You see that? So our cosine of theta shall be equal to negative 1, then plus. So inside here we have 4 times 9, that is 36. So 36 times 4, isn't that 144? Yes. So 144 then plus 1, because remember, we are having a negative here and a negative here. So it becomes a positive. Now we add it to 1, that will be 145. Then out of 18. Also, cosine of theta is going to be equal to negative 1, then minus the square root of 145, then out of 18. Okay, we consider the plus and then the minus. Now, when we are getting the values here, I'm going to use the unit circle, and all are positive in the first quadrant, sine is positive in the second, only tan positive in the third, and cosine only positive in the fourth quadrant. So we have 0 degrees, then 90 degrees, this is 180 degrees, this would be 270, and then coming back here, this would be 360. That is when we move what? Anti-clockwise, and the angles are positive. Then when we move clockwise, the angles are negative. So that means this will be negative 90 degrees, and then this will be negative 180 degrees. Okay, now if I project an angle here, which is theta, then also this other side, opposite angles are equal. You see, then same thing here, theta, and also here, put theta. So this is 180 minus theta, if you move like that up to here, okay? Then this one can be 180 plus theta. That is if you are coming like this, you get it? Then 360 minus theta when you come like that. Now, theta here is going to be equal to the arc cos of negative 1 plus root of 145 out of 18. Now, this part here is positive. So since it is positive, then we are going to get the answer in the first quadrant. The other answer would be in this quadrant here, where cosine is what? Positive. So I would say my first answer is that acute angle. Then the second answer would be this one. Okay, but this one would be greater than 180. Remember, our domain is from negative 180 to positive 180. You see that? Now, instead of coming like this up to here, I will do this. I will just come down like this. You see that? And it will give me the negative of this one, because it is the same angle here, which I've gotten just as the one that I'm going to get here, but here it is going to be negative. Okay, so let's check this answer out. The domain was given in degrees, so make sure your calculator is in degrees. Shift, then cosine, we get that arc cos, then we have negative 1, then plus root of 145, then out of 18. This one gives us 52.2. 52.2, that is to 1 decimal place. And Here I'll take two answers, the plus and the minus. Okay, I'll put plus or minus. I would have taken 52.2, and then the other one is 360 minus 52.2, because that is where cosine is positive again. But instead of taking this one, I instead go down like this. Are we there? And by the way, one other thing you need to know is that cos of a negative angle is always equal to cos of the positive angle. Okay, for example, if I say cos of 30, you can see that it is root 3 over 2. How about when I say cos of negative 30? You still get root 3 over 2. Why? Because when you move down, you get that negative acute angle here. You are falling into the place or the quadrant where cosine is negative. You see that? So that is that. Now, when we come to this other one here, cos theta is going to be the arc cos of negative 1 minus root of 145, then out of 18. So since this one is a negative, the whole thing is a negative, the calculator is going to give us the angle in the second quadrant. Now, moving from here up to here, it is actually the same way as moving from here up to here. Because remember, this is the theta here and also the theta here. So if you move up like this up to here, it is the same way as moving from here up to here. You get it? And also, these are two quadrants where cosine is negative. So in the second quadrant and also in the third quadrant. So I would get 180 then minus theta. That is if I ignore the negative and then I get the acute angle. So I say 180 then minus the theta, and then the other one will be 180 plus what? Theta. So I would get an angle in the second quadrant and an angle in the third quadrant. You get that? But in this case, since I have negative angles, our domain is this one here. So instead of me getting another answer by getting 180 plus theta, which goes beyond 180, I'll instead move from here and then I come here, which will be the same as moving from here then up to there. You get it? Okay. Arc cos of negative 1 minus 145. Then down here, no, it's actually square root, pardon me here. Square root of 145, then 18. This one gives us 136.4. 136.4 degrees. So you are moving up to here. It is in the second quadrant. The same way you will move like this. But remember, when you are moving clockwise, the angles are negative. Okay, so I will also put here plus or minus, as simple as that. So therefore, our theta is equal to plus or minus 52.2 degrees, and then plus or minus 136.4 degrees. That is that. Question 6. An arithmetic progression has the first term a and the common difference 2. The nth term is 55 and the sum of the first three n terms is 5760. Find the values of n and a. Now we have the nth term is always given by a, then plus n minus 1 d, not so? A, which is equal to, that's the nth term. Now they said the capital N, the nth term is 55. So I will say now that a then plus n minus 1 times the 2, the common difference, then is going to be equal to 55. You see that? So let me in fact write this one here, that the nth term of an AP is given by a plus n minus 1 d. So If they have said the capital N where there is small n, then you are going to put this capital N, as simple as that. Then if I can open the brackets, or I can make this A the subject of the formula, we shall have 55. Then this is 2 times the n, so we shall have minus 2n here when it crosses, and then this is minus 2 when it crosses, it becomes a plus 2. So our A will be equal to 57, then minus 2n. I keep this one. Then we also have something else given. They said the sum of the first 3n terms. You know that sum of the first n terms of an AP is given as n over 2 into 2a, then plus n minus 1d. Now, if you have sum of the first 3n, that means wherever there is n, you are going to put that 3n over 2, then into 2a, and then plus 3n minus 1, okay, then times d, which d is a 2, and then this one is 5760, not so? This implies that we shall have 3n over 2 into 2 times our a is this one here, which is 57 minus 2n, then plus this will be 6n minus 2, then this one is equal to 5760. Now we are getting an equation here in on the capital N. You see that? Let us simplify what is inside here. Let me see if this one is divisible by 3. 5760 divided by 3. Yes, it is. Now I'll say here, first let us multiply inside there. 2 times 57, that one will give us 114. So 114, then minus 4n, then plus 6n minus 2, then this one will be equal to 5760 times the 2, then out of 3. I'm taking away this, okay? But the whole of this is multiplied by the n outside. Now, you have n here, and this is 6n minus 4n, that will be 2n. And then, what else? 114 minus 2, isn't that 112? Positive 112. And then this other side, remember this one goes here, 19 something, right? 5760 divided by 3, that is 1920. Okay, then if we multiply by 2, that one will give us 3840. 3840. So when we multiply all through by n, we shall have 2n squared, then plus 112n. Then I can bring this one this side, 3840. Then this one is equal to 0. Then I can divide all through by 2 to simplify this quadratic equation. We shall have n squared, then plus, this one will give us 56. Yes, 56 of n. And then this one, 38, that will be 19, and then 20, which is equal to 0. So I can solve this quadratic equation using the calculator. Mod, then equation is 5, and then 3 is quadratic. We have 1, then we have 56, then we have negative 1920. And this is 24, and then negative 80. Negative 80, and then 24. So meaning, if I bring this one back, we shall have n plus 80, and then also bring this one back, you will get n minus 24, which is equal to 0. Now n, these are number of terms. You can say first term, second term, so n cannot be a negative. You get it? They have to be positive values. So therefore, our n Okay, therefore our n is going to be equal to 24. Okay, so that is that. Then we can substitute, and then we get the value of a. A is therefore going to be 57, then minus 2 times the 24. So you have 57 minus 48. So 2 plus the 7, isn't that a 9? So that means a is equal to 9. As simple as that. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next video.